Using the KNeighborsNeighbors or KNN algorithm in Python is super simple. First, import the libraries. To use KNN, we need to import the KNeighborsClassifier from the sklearn.neighbors library. I'm also going to import the standard scalar from the sklearn preprocessing library, since for KNN, it's good practice to standardize your data. Next, we just need to import the data. So we're looking at the Titanic dataset, which is a classification dataset. So survived is the dependent variable, and we're going to be using all these independent variables to try and predict survived. Next, create the training and test datasets. So in this example, I'm using 20% of the rows to test our KNN model. That means 80% of the rows will be used to train our KNN model. As I mentioned before, with KNN, it's good practice to standardize your data because KNN uses a distance to calculate the model. Any large values or outliers could have impacts on KNN that we might not anticipate. So it's good to standardize it. So we're going to standardize our XTrain dataset, and we're going to standardize our XTest dataset. Now, the big question with KNN is how many neighbors do I need to use for the algorithm to get the best results? What you could do is you could create numerous KNN models using different values of K and test the results. But since we're in Python here, what we can do is we can just write an easy loop that'll loop through and create a model using each value of K that we specify. So in this loop, we're going to say, start the KNN model using one neighbor, and then iterate incrementally by one all the way through 10 using the 10 nearest neighbors. And what it's going to output the F1 score and the accuracy score into a plot and table so that we can then visualize to see what is the best value of K to use in our K nearest neighbors model. So after we run the loop, we can then plot the output of the model here. And so when we plot the output, you can see F1 score is the blue line. And it looks like about when we use a value of 4 or the 4 closest neighbors, this provides the highest F1 score. It also provides, it looks like, the highest accuracy score as well. I personally like to use the F1 score when measuring what's the best value of K to use in the algorithm, since the F1 score will penalize any false positives and false negatives in the model, while the accuracy will not. So you could use a line chart, or you could use a table here to look at what is the best value of K to use. If in your for loop you use more than 10 rows, if you're using 100 or 200 rows, it's kind of hard to look at a table to find the best value. So the easiest way to do that is to write a function that looks up the max value for the F1 score from the table. So if we do that, it outputs a value of 4, which shows that our F1 score is about 76%, while our accuracy is about 81%. So now that we figured out the best value or the most optimal value of K to use, let's build our final model. So we're going to use the KNeighborsClassifier, and then within that function, we're going to specify the number of neighbors equals to 4. We're also going to specify the weights equals to distance. That way, if there's any ties, it'll use distance to break those ties. We're then going to train the KNN model on our training data. So we're going to use KNN-model.fit and use our XTrain and YTrain data. And the KNN model is what we called it up here. So just use the .fit function on your KNN model that you created. We're then going to test our KNN model using our test data set. So first of all, we're going to transform our YTest data set into a data frame. We're then going to use our KNN model and predict each row of the test data set, and then add that as a new column to our YTest data set called predicted. To see how accurate our KNN model is, we're then going to use a confusion matrix using the same YTest survived and YTest of predicted. To really see how accurate it is, we're going to run the accuracy score using our y-test dataset. And it looks like when we use KNN equals to 4 for the nearest neighbors, it has an 81% accuracy rate. That means our misclassification rate is 18%. Our sensitivity for KNN here is 72%. That means it accurately predicted the true values 72% of the time. And our specificity is 87%, which means it accurately predicted the false values or the zero values 87% of the time. So it looks like our KNN model for this data set is better at predicting 0 than it is 1. If this video is helpful, please like it and also subscribe to my channel at Reasonable Data Science to learn more tips and tricks on data science.